So, we are starting to get somewhere with this tank. And while it might not look like much now, these coral fragments are already hard at work, adapting to their new environment. It is, after all, what coral do best. And that is largely thanks to one type of cell in particular, the primordial stem cell. These cells are the first of the party in the creation of a new coral, and it's looking like they are what make Weismann's immortal germline possible. Because these primordial stem cells carry essential germline information across generations. Information like traits. And by performing this service, they give newly formed germ cells what they need to maintain their identity over time. And these primordial stem cells aren't just a memory bank between generations. They also stick around throughout the life of the organism, acting as blank slates, if you will, and remaining available should needs arise. If they do, these cells can differentiate or transform into completely different, task-specific cells, whether germ or somatic. Meaning that if a tissue cell dies, a stem cell can simply differentiate and replace it. Or if a piece of tissue splits off from the mother colony, it carries with it not just somatic cells, but also more of these primordial cells, which can then become germ cells and provide the material blueprint needed to turn fragment into colony. And the reason stem cells can do all this is that they're capable of unlimited self-renewal, meaning they can proliferate on their own, indefinitely. And this is what allows them to replace cells throughout a coral's life, maintain its juvenile state, and prevent things like cancer or even death itself. Wow, so coral really are playing by different rules. Without a doubt, they have incredible capacity for survival. But does this mean they can escape climate change? Sure, they may have stem cells that self-renew, but what if the ocean turns into a hot tub? Can coral really change enough to survive that? These are valid questions, but fortunately, primordial cells do have one more capability, one that might be the superpower coral need. Weismann and Darwin believed that mutations would be key to species changing quickly. And indeed, it looks that way for coral. Because it turns out that many mutations first occur in these primordial stem cells, before copying over to germ and somatic cells, just as Lopez Nandam and her team had suspected. For example, let's say a piece of Acropora hyacinthus develops a beneficial mutation within a stem cell, which then self-renews. Now, the mutation exists in multiple stem cells, which themselves can transform into other types of cells throughout the body. So what was one copy of a mutation in a stem cell is now multiple copies spread over germ and somatic cells. And now this mutation can be tested for usefulness in the form of tissue, gastroderm, or reproductive cell, meaning natural selection can act on it throughout the body, giving it a higher chance of benefiting the coral in one capacity or another. And this variation throughout the body has big implications for researchers working to help coral adapt, because it means that unique mutations can exist in every branch of a coral. And that if, in a sample colony, one fragment in 5 survives higher than normal temperatures, it can compare the genotype of the surviving branch to that of the losers, and isolate the mutations responsible for that heat tolerance. And now that they know which mutations allowed it to survive, they can grow this winning branch into a sexually mature colony, breed it with potential losers, and work to increase the presence of these adaptive mutations in the next generation. Finally, this new generation can be outplanted back onto the reef, encouraging the population at large to shift towards heat tolerance. This is what's known as assisted evolution, and it's likely to be a major tool in the battle to save coral. And while the success of mutations in the wild will still be subject to natural selection, instead of the process taking generations and happening at the population level like it does in most organisms, in coral, it's happening in only one generation, in a single colony. Yeah, you heard that right. And it's all thanks to this primordial stem cell lineage, which develops mutations over time, allowing the germline to remain more flexible than most animals on Earth, and allowing coral to build a better blueprint of themselves with every branch. Many theorize it's the reason coral are so resilient and can survive for hundreds, if not thousands of years. And it's why the headlines in the media touting supercoral or climate resilient coral are not just hype, but reflect the very real ability coral have to rise to the occasion and change quickly when circumstances demand it. So, it may be the age of climate change, but coral are highly adaptable. And now, they just need scientists to help them help themselves, while the rest of us help by letting off the gas pedal. We, like coral, are going to have to make some changes. But I'll stop short of telling you what those changes should be. After all, I didn't want this to get political. I don't want to divide people. I don't want anyone to unsubscribe. I just want to keep it one big happy coral family, right? Let's just keep it one big happy coral family, and everyone can make up their own minds about what to change. But for the record, it should be to eat less meat, consume less, fly less, drive less, vote, and recycle. All right, as always, be good to the planet, my friends, and we'll see you next time on Coral Explorer.